Hey there, I'm Said, and here is the fourth episode of Unreal Engine for virtual reality development. In the previous lectures, we discussed about how we can implement the hand and movement, and in this lecture, we would like to talk about teleportation. Teleportation happens from one point that we have the location of that point, and we would like to move the character in another position using something like projectile or the curve, something that we know from the basic physics that if you throw something, it will have a curve path. In the last point, we will have another location that is the position that we would like to travel there or teleport there. This curve, we can call it trace, that can be a kind of projectile. And also we have the angle that we would like to throw, the speed, or more accurately, the velocity, and also the location that we would like to start throwing our projectile. We can consider the first location as actor or pawn location or our character location, the other one as a hand location, and the last one as a destination location. Also, our destination should consider the point that has some collider or collision, and we can define which kind of channel we would like to use for this collision. For the trace point, we would like to also use Niagara particle system later that will cross this path or this trace, but we can discuss it later during the course how we would like to implement it. As I discussed, the last point can be a kind of collider. Let me just mark it with a bigger pen that is more visible as a collider point or the collision that we have that later can be also used the area that inside the nav mesh system, that whenever you define somewhere that character can move, we can also teleport there. It will be very handy when we are developing our game. Okay, let's get into Unreal Engine and discuss what we have. If we go inside our blueprint for our character, and if you remember, we had this input action for the VR movement that when you press the trigger button, we can move forward. We can create another input action for the teleportation system, and this input action can consider, for example, for Valve Index, the thumb stick y-axis, and for the Oculus, the same one. For now, I'm just considering the right hand for the teleportation, but you can also use both hands for this. For now, I'm making it simpler, and later we can extend it. Also, it's a float variable from -1 to 1, and we can pass it as a ratio or as a value. I will get an event system to this input action. And now we would like to implement our functionality. This time, I would like to add another component to my VR character base class blueprint. And in order to do this, I will create another folder inside my C++ folders. It's easier to do it with Rider. Just right click on the public and then go create another directory. I will call it components. And easily I can now add another Unreal class here from the type of actor component. And if you want to know, actor component doesn't have any specific location in the world, but the scene components has also the location. It's the difference between them, the main difference mainly. Okay, I created my component class, and this component class will take care of all of the teleportation systems that we need. As you can see, the writer already created two folders for us, one in private and the other in public folder of our source folder, and put the C++ file in the private one and the header file in the public one. Okay. The first thing that should happen here, let's me clean up a little bit the code. I can also clean up more, but I will keep it as it is for now. Just I will move the tick method inside the public part, but later you can add also more functionality there. Okay, we need to add another method to begin our teleportation. I will use a U function and blueprint callable macro because it will be helpful later. We can also call it in blueprint, and I will call it void begin teleport. because the beginning point of our teleportation. It might be successful or not. I simply call it begin teleport, and I will generate the definition for this. This definition should take care of the beginning of our teleportation. As you know, this teleportation should happen when we press one button, and it should update itself on a runtime. It means it's some kind of update method, or it's a tick method. In order to do this, I recommend here to just use a simple if method. Maybe you can use also other way to implement it, but for now the simple if method can work. We need first to start tracing for the teleport location, and then activate the trace visualization inside that tracing for teleport rotation method. I will remove this active visualization for now, because in this lecture we would like to make it just simpler by having only the tracing and seeing whether it's worked or not. And in order to do this, we need another boolean here that takes care of whether we are tracking for our teleport rotation or not. This boolean can be protected because no other classes needs to know about it. It's inside this teleportation component, and I will call it b is tracing for teleport location, or is tracing for teleportation, just simpler. And I will check inside my tick component that whether this boolean is true or false. If it's true, then we can trace for a teleport location. In Rider, if you alt enter on the method that you did not implement, you can easily implement it inside the header file. As you can see, I'm doing it here, and it doesn't need to be a U function because it's inside this component, and we do not need to have access to it in our blueprint. Okay, inside this begin teleport, then we will first make the boolean for tracing to the teleport location as true. And when this one will be true, then trace for teleport rotation location method will be called. The trace for teleport location method should active tracing visualization. If we have it later, we can use it also for the debug for now, but I'm just writing down some comments that I will use Niagara system later. Also, we should use something in Unreal Engine that we call it projectile prediction. As you see here, the green line shows the projectile. However, the starting point is a hand that in virtual reality is higher than the ground, but yeah, as a 0-0 location, you can see it like this. And it should throw a projectile and see where is the location that it will hit the collider. In order to do this, we will use gameplay statics. And one of the methods inside the gameplay statics is predict projectile path. The first argument is a work context object that we will use this component class. And then we need to create projectile path parameters. In order to do that, I will create another variable called from the type of fPredict projectile path parameters and call it simply predict params. Some of the parameters for these predict params, you can play with them. For example, whether you need a trace complex, that here I will make it false to make it simpler to calculate. But if you find some problems, you can also trace for trace complex. Also, I would like to have trace with collision and based on the channel. And the channel that I will use here is visibility channel. You can also create your custom channel here and just trace for that one. The first thing that we need when we are considering predicting projectile paths is start location. If you remember, this start location is a location of our hand that as we shown in the picture before. In order to do that, we need to have access to our hand, and this hand is a part of our VR character object. In this way, we can get the owner of this component, because we will add this component to our character blueprint. When we get the owner will return the actor that owns this component. And if we cast it as a VR character base, we will have our VR character. We need just simply to create a maybe global variable for it, or a member for it, call it VR character, and we will use the macro view property visible anywhere, because we will not modify it anywhere. And also we would like to have the blueprint read only in the case that we need to do something with it later. I will also use the category of the character to make it more clear later if we need. Great. Now, whenever we need our reference to our character, we can use this VR character pointer. For the start location, then we should get a reference to the hand that we have. Also, I will add it to do here that later I need to make it for the both hands, but for now it's only working for one of the hands as an example. Okay, the start location, as we mentioned, can be a VR character, and then we can, if we check the C++ class or the header file of our VR character base, we can see we have the right motion controller, a reference to these components that we created before. You can also use a skeletal mesh if you like, but here I think it's enough to use the right motion controller. And then we will get the world location of this component. Now we can use this location as our starting location. Also, as we will not modify this variable later, we can make it constant. Next parameter that we should set inside our predict parameters is a launch velocity. If you remember, we are throwing this projectile through the pass, and this launch velocity defines how far it can go. Accordingly, if we go to our teleportation header file, we can create another member variable and call it maybe launch velocity or something similar. It can be edit anywhere, and also Blueprint should have access to it in case you would like to change it in the gameplay. I can call it teleport trace projectile velocity, and it will define the length of the path that we will have later. I will use it here, teleport trace projectile velocity. And if you check the launch velocity, it's a vector that defines the vector that we are throwing this object. It means the direction of the forward vector is also important. In order to do that, we can get the forward vector of our right motion controller from VR character. And if we multiply it with the velocity that we defined as a float variable before, it will give us exactly the launch velocity vector that we need. Also, as I mentioned, you can also play with the other parameters inside the predict parameter variable, but for now it's enough, and I think we can use it here. The next things that we need is another variable that we can save the result of this predict projectile path method. In order to do that, I will create another variable, and I will call it predict result. Here it will be only a reference to this variable that we created. And as you know, probably the predict projectile path is returning a boolean that whether it's successful or not, and we can now use an if method. Accordingly, if the predict projectile path is successful, we can show it returns true, and we can show a location of it or using the predict results, and otherwise we can return error or just showing nothing. Let me just rename them to have more consistent naming. And here I can use this predict result and then getting the hit result, and from that I can have the location that it hits the ground. The simple way to check whether it's working correctly or not is just by printing it on the screen. I will use the GEngine, and inside the GEngine there is a add on screen text method that's that add on screen debug message method that you can add something to the screen. Here I will use also the printf of the string that can help me to print a value that I need. I make them just appear for 10 seconds in case that I would like to check them a little bit more, not immediately appearing and disappearing. And also the message that I want to show here is that the predict path as a vector. I will change the text to the predict location to make it more clear, and also from the predict results we will get the hit results and then the location. I need to convert it to a string and then use override method with start that will convert it in a way that we can print it. Great. I need to just also add some comments here that I know this part is only for the debugging, and I can deactivate it later. Also, I do not need that line anymore. I can have also the else condition for the main predict projectile path, and here if it's not successful I can print that it's not hitting nothing. I will use the green color for the successful condition and the red color for unsuccessful one, and I do not need any value here. Also, great. Let's test it in action. I will build the component and C++ classes. Oh, it seems to be successful. Now if we go to our blueprints, we have this teleportation inside the components folder, and also we can add it here as a component to our blueprint. When you add this one, you can see also the component or the variable that you exposed also available here inside the teleportation category. I will get a reference to this teleportation component inside my blueprint. I need to use the value that I have from the trigger button or any other input action. Here is the y-axis of my thumbstick, and I should check whether this value is greater than something to make sure that not any accidental action is considered. For example, I will consider here 0.1. If it's greater than that, then it's good enough to do the teleportation. And teleportation will happen by using the begin teleport method. Also, if the value is less than 0.1 or it's negative, I would like to use the end teleport method later. Let me quickly also implement this end teleport method. It will be again a view function, blueprint callable, and I will call it end teleport. There is a mistake in parentheses, and now it's good. We are good to go. Let me also generate a declaration for it. And the only things that should happen in teleport is making the boolean for the is tracing for the teleport location false. And we can easily now build our file and to see whether it's working. Great. If we go again inside our blueprint, we should have access to this method that we created, and we can connect it to the false condition of our branch. Let me just clean up a blueprint. And I can also connect it to the complete method. In the case that we release the teleport button, the end teleport should happen as well. I should let you know that the teleportation will happen when we release the button. It means inside the end teleport later we should make the functionality. Now let's test it. As you see, when we are hitting the ground or pointing to the ground, it's green, and when we are not pointing the ground, it's red. Let me easily create a simple object for our teleport location to make it more clear where is the teleport location that we have. I will use the blender just to make some simple model for our teleport location. The idea that I will use here is just having a placeholder for the location that we have, and an arrow that shows where is the teleport location, and also push the focus of the user towards that location. Here, in order to make it also a little bit more interesting and animated, I will use the vertex color because I can easily export this information inside the shader, and inside shader I can animate this object without necessity of having another material for each part, because I will like the arrow to be goes up and down, but the circle should stay as it is. I just make a simple arrow there, then assigning a vertex color, something like red to the arrow, and then black to the ring. The black means there is no movement, and the red is the full movement for that arrow part. I will export it as fpix without any specific setting, and inside Unreal then I can import that fpix file. Perfect. Now we have our fpix file. We should just consider that this object should not have any collision, otherwise it makes a problem. It should be a totally only a visual object. However, we can also use the UI, but I like in VR to have it as a 3D object. Then I will create another material to be, by using the vertex color as a base color, and as you can see, it applies correctly. I will create another variable inside my shader because I can control it later as a material instance, and call it maximum displacement, and the other one for the frequency because I will use the sinus wave that goes up and down. In order to make it just positive, I will divide by 2 and then add 0.5 to it, and I will multiply everything with maximum displacement and defining a vector that I want to move. It's a vertical vector for it, but I would like to make it to force it to only move the parts that has the vertex color of 1 for the red channel. In that case, I will use the red channel of vertex color and multiply it with the result that we have for movement. I also defined a color for my main object. But it will be also nice if we use 2 colors later. I define metallic and roughness parameter here because it helps me to make to have more control over it later. As you can see, with 1 color, it's nice, it's moving, but maybe it's better to first change the shape. to make it more arrowy, and I will just move these two edges a little bit inside. It has the better shape now, and yeah, you need to just re-import your file. I will add another color to distinguish between the bottom part and the main part of our teleport indicator. And in order to distinguish between them, I layer between color according to the vertex color red channel. I just switch the colors, and also I will multiply it with something and call it emission, because I would like to have a little bit of emission on my objects to make it more distinguishable even in the dark area, and with lumen it would be also very nice to have it. I create another material instance from it to have control over the color and all of the parameters that I exposed. And as you can see here, I'm changing all of the parameters like roughness or metallicness. And also I think the orange, it would be better, it's more clear for the arrow. The only point is I will rotate it 90 degrees to be the forward axis state at the X location. And now I can expose it inside my blueprint. In order to do that, I need to create another component from type of the EU static mesh. I will give it a category of components teleportation as a subcategory of components. I will call this teleport indicator, similar, or teleport location indicator, similar to all of the other components that we created before. We need to create default subobject for it and then attach it to the placeholder that we have. That here is the root component, because it doesn't belong to any part of our VR character and it can be connected to the root component. The collision should be no collision and it should be hidden in the game, and we can activate it whenever we need. Let's compile the code, and now inside the teleportation component we can deactivate the debugging text, and instead we can use this the teleportation components that we created, and we make first we set the word location of it, and it should be exactly on the location that it hits the collider, and then we will make the object not hidden in the game. And in the case that is not colliding with anything, it should get hidden. And also when we are releasing it, it's also should be deactivated. Let me build again and let's test it in VR. But before that, we need to assign our 3D mesh to the component that we created, and using the correct material. As you can see, it's available there. If we go to our scene, I can remove the test one, and it's there. And if we press G on keyboard, we can see in the game it's totally hidden. Let me now go to VR to test it, whether it's working. As you can see, when I'm pressing the y-axis of the thumb, it shows the location that I can teleport. But the problem is it's not looking towards me. In order to do that, I should get the forward vector of the camera. But this forward vector should be a forward vector that is projected on a 2D plane of the ground. And in order to do that, I will easily use uKismet library, project vector on the plane, and I will project it on the plane with the z-axis as a normal. And as you can see now, if I now press the teleport button, the teleportation indicator looks towards me, and it has very nice animation as well. The other things that I will like to do is making the hand animation working. Previously it works for the movement, but it's not working now for teleportation, and it's also in the another component we need to pass the ratio inside the begin teleport method to be able to use it. Also, we need to add another method inside our VR character base to update the right hand pose, because previously we do it without any specific method. And the ratio that we pass inside that is a ratio of our axis. I create for both hands for now, but we will use probably only for the right hand, as we did not implement the left hand in any input action. And for the update right hand pose, we can use that ratio to update the teleport pose of our right hand. This method is public, and we can use it inside our teleportation class. And in this way, we can easily have the animation for our hand and teleportation simple. I hope you enjoy this lecture. Just the last thing that you need to do to removing the teleport method that we add later previously in the blueprint, and replace it with the new begin teleport method. Otherwise it will not work. And also on the end teleport, we would like to have the 0.0 value for the pose condition. Later we will extend it in a better shape, but for now it's simple and you can teleport with animation. Thank you so much and enjoy your time.